Alright, let's look at solving a polynomial inequality. Now on this one we have the graph of this cubic degree 3 polynomial given to us to the right here, this graph of f of x. Alright, so we can use that graph to easily answer these examples here below of solving a polynomial inequality. Now example 7 here, you see we've got x plus 3 times x minus 1 squared, which is the function f of x. They want to know when it's greater than 0. So if we look at our graph, where are we greater than 0? So as we look at our graph, and I'll get a different color here, let's put it here in blue. Alright, we can see our graph. Now greater than 0, of course, here's where it touches 0. Right? Here's our x-intercepts, -3 and 1. So our graph is greater than 0, right, between -3 and 1, right? Graph greater than 0. And also from 1 to infinity, right? It goes up forever. Now it's less than 0, right, from -infinity all the way to -3 down here. So again, you can see your graph between -3 and 1, right? And here, and also 1 to infinity. So let's put our solution set of all of these in interval notation. So again, as we look at our solution set, alright, let's put it again in interval notation. So all x values greater than -3, less than 1, or 1 to infinity. Right, so there's all the x values where our polynomial function is greater than 0, right, and for this cubic degree 3 polynomial. And let's look at the next example, example 8. Now in this one, you can see they're asking for this example here of where it's greater than equal to 0. So we're going to be looking back at this graph, and we're going to be including, of course, right, these x-intercepts. It's the only difference. That's where it equals 0, the x-intercept locations. So looking at, showing that here on our x-line, as we're looking at all values of x satisfied. So here at -3, we're going to include that number. And of course, here at 1, we're going to include it. So we're shading in where we see it. We're shading all real numbers greater than or equal to -3. Right? So again, that's -3 all the way to infinity. So there's our solution set. So let's go ahead and write it over here. Our solution set, all real numbers x greater than or equal to -3. Alright, so again, interval notation, preferred form with an infinite set of values. Alright, let's take a look at the next example. So in this next one, right, we're looking at a polynomial, right, being less than 0. So now we're looking back at our graph, right? We're looking at our graph here, and we can put it in a different color, put it in red. As you can see, our graph is less than 0, right, over to the left of -3, right? That's the only place we have negative values for our function, right? All these function values are negative for all the x values less than -3. So we want to show that less than 0, right, would be all real numbers less than -3. So as the interval goes, -infinity to -3 with a parentheses. So writing in our solution set, right, we're looking at a solution set of all real numbers less than -3, -infinity to -3 with a parentheses, not a bracket. We'll include -3. And then in our last example, we want to include the zeros, right, less than or equal to 0. So that means we're going to include -3. So we need -3 in our solution set. So as the interval goes, right, -infinity to -3 with a bracket, right, on that. So that's our solution set for this last example here, example 10. So all real numbers less than or equal to -3, bracket, right, we need to include it. Right. So again, here's the examples we're getting into solving polynomial inequalities. If we have the graph, right, we can easily see the solution set from the graph. All right, so I hope this helps as we're leading into this new topic.